Welcome to our program introduction for the Robotic Systems Engineering Master here at the RWTH International Academy. My name is Nadine and I'm the Application and Admission Manager from the Intake Department, and joining me on stage is Professor Corves, the Director of the IGMR and also the Academic Head of the RoboSys program, and he will be giving you not only an introduction to the IGMR Institute but also to our most famous master program. And after his presentation, you have the chance to ask him questions about the program. Okay, so already maybe think about the questions you may have and write them in the Zoom chat after we have finished the presentation. And without further ado, I hand over to Professor Corves. Enjoy the presentation.
Thanks, Nadine, and welcome also from my side to this webinar. And I will talk both about robotic activities at IGMR, of which I'm the director here at Aachen University. And in fact, I do that already for quite some time. So in 2000, I started as a full professor at IGMR. But just as a short introduction to my person, I also did my PhD in Aachen. I did my diploma. At that time, we did not yet have bachelor and master, but it was the diploma. And I did that a long time ago. I really have to calculate. I think it was 85? Yeah, I think it was like 85. And then after that, I continued as a PhD candidate and finished my PhD in 1989. I stayed a little bit more on a research project as chief engineer at the institute. And then afterwards, I went for an industrial job in a company in Switzerland, and as already said, I came back in 2000. Okay, let's have a look at the agenda of today's webinar. As I mentioned already, I want to introduce IGMR and its research areas, and then I will more concentrate on robotics research, and then I will tell a few words also about the Master of Science in Robotics Systems Engineering and just a few closing remarks. Okay, so the video that you see right now shows the collective building of mechanical engineering, and just to show the size of mechanical engineering at Aachen University, I should say that this building, even though it's an 8-story building, just houses about 5 to 10% of mechanical engineering. So there are a lot of other buildings where you find activities of the mechanical engineering faculty. And what you also see in this video is a little bit of the scenery, the historic scenery in Aachen. And just to mention that Aachen is originally a Roman foundation, more than 2,000 years old, and I just saw some news showing that they excavated some human remains, possibly Roman, but maybe only Middle-Age remains on one of the central plazas in Aachen. My institute is not as old as that. It was founded in 1959. We are located close to Belgium and the Netherlands in the westernmost part of Germany. So when you come to Aachen, you not only have the chance to experience German culture, but also Belgian culture and Dutch culture. And there are some similarities between these cultures, but nevertheless, it's a nice experience to also realize the differences. And apart from me, there's also Professor Hüsing teaching and researching at IGMR. And in fact, you will also meet him in at least 2 of the lectures that are offered within the Robotic Systems Engineering Master. Altogether, we have 30 people as research staff, almost double the number of student assistants, and student assistants might be an experience interesting for you also. So I would say after 1 or 2 terms, once you have some list on your grade list, we will be able to judge if you can also take part both in teaching or research related to robotics. Typically, our lectures reach more than 3,000 students per year, so that's quite a large number. And our revenue is about 2.5 million euros per year. And of course, we spend that for teaching, for research, and especially also for research together with industry. At IGMR, we are not only doing research in the area of robotics, but we are also doing research in other areas. One of those areas is mechanism theory and kinematics, and some of you might already have taken some courses in that area, talking about crank and rocker mechanisms, talking about grippers, talking about slider crank mechanisms. Then we deal also a lot with dynamics of machines and vibration technology. And I think you know also some specifics of dynamics, especially the single degree of freedom, 2 degree of freedom, and multi-degree of freedom systems. And then, and that is really by far the largest area in which we are doing research, is robotics and mechatronics. But of course, all these three groups are not completely separated, but interact with each other, so that also in robotics, we take advantage of knowledge in mechanism theory and dynamics. The mechanism theory group deals with the development of mechanisms, so different types of mechanisms, as I have mentioned before. And specifically, we are also developing a software that enables designers which might not have full experience in mechanism theory to still develop solutions required for their machines and processes. Then we are also engaged in product development, but not only just developing products, but also developing methods for product development. And then, as a link to robotics, we are also dealing within the group of mechanism theory a lot in handling technologies. Handling technology means grippers and all kinds of end effectors that you want to use by a robot. When we are talking about machine dynamics, then it's mostly about the simulation-based design of dynamic systems. And the examples that you see in these slides are mostly from mobility areas. Either it's micro-mobility, individual mobility, for instance, through bicycles. It is let's say rail mobility, talking about rail cars. The picture that you see in the slides in the middle is a bogie of a rail car, which was the subject of research in a cooperation with the Siemens company. I guess that a lot of the students just listening here from India are aware that there is a large program in India going on about creating new rail lines, also building new rail cars, locomotives, and that is really done together with Siemens company especially. And then on the right-hand side, you see a suspension system of a BMW, where we also did a lot of model-based, multi-body dynamics-based analysis of such system, especially for driving simulators. Then another part in dynamics which we do specifically is research in so-called pick-and-place robots, delta robots, and that is something that connects, again, this dynamics group with robotics. And then we are also dealing a lot with vibration control, and talking about control. Obviously, control is sort of a necessity in all types of robotic research, because all the motions that you create with a robot need to be controlled in order that the system really functions well. Okay, so that is just a short overview about our research areas, and now I want to specifically show the robotic research. Of course, as already mentioned before, this is the largest group, and one part of the research we are doing in that area is to achieve higher levels of autonomy, especially in the area of human-robot collaboration. So I think you've learned already from news and so on, possibly with your own experience in robotics, that human-robot cooperation, collaboration is becoming more and more important. And of course, besides that, there are also new applications. We are dealing a lot with robotics in additive manufacturing, where we use the robot in order to improve additive manufacturing processes. And another thing that we are often doing is to develop procedures for motion and task planning. And especially if we are talking about task planning, then it means that in a lot of scenarios, it's about a given state that needs to be transferred to another state. Possibly that products are assembled and manufactured, and then we have to come up with a correct sequence of interactions between different agents. And such agents could either be robots, could be humans, could be machines, could be mobile platforms. And then, of course, we also have a lot of tools, and the combination how to address the different agents, when to ask the agents what to do, that is what we are dealing with. And now, I just show, I think it is 3 examples of robotics research. And the first one that I show is a European Union project. It's called SHAREC, and it deals with safe, healthy, and environmental friendly ship recycling. So the main objectives are that we want to involve and adopt innovative robotics, use data and AI systems in the ship recycling industry. And maybe some of you know that typically ships are recycled by just hauling them on the beach and disintegrating them with welding torches manually. So there are a lot of environmental risks combined with that, and we want to improve the occupational health and also the safety condition, and of course regarding the environmental impact, we want to prevent contamination. So the contributions are that, first of all, we have a semi-autonomous preparation process using AI-powered drones in order to inspect not only the interior of the ship, but also the exterior, trying to identify hazardous materials. And then we have a databases that we can use for AI processes in order to do the following planning. And that means that we want to automatically set up a recycling plan, and in order to set up that recycling plan, we use digital twins of the ship, and in fact, it's sort of consecutively building up that digital twin. Partly we might be able to already have some, let's say, CAD data of the ship, but typically in a lifetime of a ship, which may not be too long, maybe 20, 30 years, in the lifetime of the ship, usually there are also changes done to the ship, both the interior and the exterior, and not all these changes might be documented in some database. And then, based on that, we can automate the cutting and paint removal processes, because in the end, what people are interested in are the materials like steel, bronze, copper, and so on, which have a certain wealth, and this should be retrieved. So typically, if a ship needs to be wrecked, the price of such ship is still in the area of $1 million or so. So you also want to do the whole process as quick as possible and as less costly as possible. And this shows just a few animations of systems we are using within that project, and you also see a lot of different names from companies, let's say all over Europe, from Germany, from Italy, from Belgium, from Denmark, from Sweden, from Finland, Greece, also Turkey is involved. In fact, the lead in that project is through a company, an engineering company in Turkey. Okay, another research project that I want to show here, and somehow the origins date back to when I was working with a Swiss company I was mentioning before, which is dealing with production of machines for glass manufacturing, for container glass manufacturing, but the project itself is not that old. We started that about 5 years ago, and it's about robotized job changes. You possibly know that in all types of packaging or processing machines, different products can be produced, like different types of, in this case, bottles, size and shape. And then, of course, I need to do a job change. And while doing the job change, the machine is not productive. So I need to do that job change as quickly as possible. And now the video that you can see, and hopefully you can see that nicely, shows such a machine. And the bottles that you see being on the conveyor belt just up front, these bottles have a temperature of about 500 degrees C, so you don't want to catch them by your hands. The glass drop, the glass gob that drops into the machine has about 1000 degrees. So we are talking about, let's say, environmentally situation that is not really that nice. So we want to replace the manual tool and mold change by robots. Because it is dangerous and accident prone, and sometimes, as you can see on the right side picture, people are even climbing on that machine while still the hot bottles are being produced. So that's really dangerous and accident prone. It's also labor intense, it's hard work. The mold parts may weigh up to 20-25 kilograms, and you always have to move over to get them out of the machine. And the project question here was, can we use robots at such a machine to relieve workers from their hard work? So the project goal was to do an analysis of current work processes and also to identify suitable steps for robotic use. And typically, I would say, even though this is for a specific machine, you can think about a large variety of different machines where you try to find out how to use robot in the specific scenario. And that's also what you're going to learn when you register for the Robotic Systems Engineering Master. So it's about the development and also illustration of realistic concepts. And the next slide, exactly this one, shows some examples of that machine. In the upper part, you see the combination of two machines, which could be simultaneously operated by one robot. So there are different possibilities. Either the robot is hanging from the ceiling or the robot is mounted on a mobile platform. So in this case, the robot can be used for the positioning, collection, transport, and also safety. So it's not only the robot itself, but also mobile platforms. And of course, for supervision, we also need suitable sensoric systems. And then, of course, the trajectories need to be planned collision-free for the main task. So effectively, we have developed some concept to do that. Another example, which is from similar industry, is about automatic robot-guided form scan and coating. And typically, what we are aiming at today when we're talking... Sorry, I should take some water. When we are talking about robotics in the industrial context, we are more and more talking about autonomous systems. And autonomous systems means that there shouldn't be any operator who line by line does the coding for the robot, for the motion of the robot, but somehow the robot should know how to move by its own, and it needs some sensors, but also some planning algorithms. And here we did something similar, and there the objective was to increase the flexibility in scanning and coating molds. In fact, these molds are those molds that are used on the machine I showed before, and our contribution was that we have have synchronized data acquisition with the robot motion, and we use MATLAB scripts for data post-processing and trajectory calculation. So the trajectory that the robot follows during the coating process is not programmed by a human, but just automatically from the data that have been acquired previously by different types of sensors. I think in this case, we used laser scanners for that. And then, of course, the trajectory can be executed through the robot control system. And the following video shows how it is done. You will see, first of all, the robot that is carrying a scanning device, and with that scanning device, the laser scanning device, it automatically finds the mold, which is set up accordingly, and then it is scanned, and then based on that scan, which you will see in the next sequence of that video, after that, we can automatically generate the trajectory. So just follow that video. That's a typical task. So this is how, let's say, the shape, first of all, is created, the shape that is detected with a sensor head. And then this is the automatic calculation. Of course, the calculation is quicker than the visualization. And during the process, you don't really need the visualization. This is just to show you how it is done. And then you see the spray head here. So it's about coating the mold using a spray. And what you see right now is just the dry test. And afterwards, we will see the actual coating. And of course, the dry test is just, let's say, for validation. And in the real process, we will only have the spray sequence, which will start directly now. So this is now with the spray on, and we can do everything. And no human labor needs to be used for that. Okay. I was talking about 3 projects. Now I realize it's 4, but this may be the most interesting one. It's a project called Demonta. In fact, it's a project that is a spring-off of our university or of IGMR. And they had a first round of financing where they sort of deepened the knowledge about what they want to do, and that is the enablement of automated dismantling or automated disassembly. And just now, I think starting from May, we will have another 18 months to further refine the idea about that. And it is especially aimed at automated robotic battery disassembly. So then we are not talking about the small batteries that you might have in your mouse or in your pointer, but the large EV batteries for electric vehicles. And just from the abstract point of view, in order to do an automated disassembly, we need to do an object identification. Then we need to determine the dismantling sequence. We have to do the detachment, and then we can finish the part removal. And of course, if we have a product made up of a certain number of parts, then we have to repeat that process at least as often as we have parts in the assembly. And we want to do that by creating so-called robotic agnostic skills, which means one skill could be identify a screw. The next skill is unscrew a screw. Then it is grip the screw, remove the screw. So these skills should be created robot agnostic, because that enables the user to use different type of robots. So for instance, screw detection could be to detect a very small screw or a large screw. And obviously for a small screw, I can use a small robot. For a large screw, I need a more larger screw, but the skill should be exactly the same, so to say, a scalable skill. And of course, in order to do that, we have to deal a lot with handling, and handling needs that certain presumably versatile dismantling grippers are developed and used. And then we will be able to combine all the skills in a scalable, profitable, and easy-to-use modules. And then typically what we have skills related to data, we have skills related to recognition, to planning, to actions, and to tools. And then we take those modules and arrange those modules such that we have planning modules, screw extraction modules, or also gripping modules. So this is what we do. And obviously, this is on a very abstract level, but to show that that can be brought to reality, first of all, on the left-hand side, you see an animation of how such a system could look like. And on the right-hand side, you see the real-world example. Of course, in that example, we are not really dealing with a real EV battery, because that would be just, from the handling point of view, too dangerous. But we have just 3D printed modules which can be disassembled using the robot. And when you see that the robot is moving, then there's no line of code behind that, just from the path execution part that has been programmed manually, but just automatically, because first the robot has a camera, and it's about inspecting what is happening, and afterwards the coding sequences can be programmed. And as you can see, in this case, the box is just placed in the workspace, and then the robot can identify where the screws are and then start to unscrew the screws. Okay, and yet another one. Yes, already from the very beginning, introducing our robotics research, I was talking about human-robot collaboration. And in this case, what we did was co-research with Ford Company. I guess every one of you is familiar with the Ford Company, and it was about the redesign of a workplace for disabled employees through human-robot collaboration. So effectively, in this case, it was about a worker at Ford Motor Company in engine assembly who had developed, let's say, problems with his shoulders, problems with his arms, and so on. So he was no longer able to apply all the force that was necessary for the manual task. And therefore, we tried to find a solution to expand job opportunities for people with disabilities. And I think that's quite important, because that is also what is happening with an aging society. So first of all, it was to especially gain important knowledge in dealing with human-robot collaboration, but also to create workplaces for people with disabilities, especially if we are able to eliminate unergonomic work situations. And in the very end, we introduced the robot. You see the robot on the screen, on the photo. Even the whole setup could be reduced somewhat, was more space efficient. So from that point of view, that was very successful. And it was extended to a project called ShareWork with artificial intelligence task planning. So that is exactly what I was already mentioned before, in order to come up with an idea how a given state can be transformed to a desired state. Also during the master course, you will learn about planning domain definition language, which helps in AI planning of such systems. And it can be integrated into ROS. For those who haven't heard that, ROS is Robot Operating System. So a lot of the programming that will be done on a robot will be done using ROS. And in order, or if we apply that we can realize high autonomy and high flexibility in planning and execution. We can easily define new goals. So the way we do the planning is also such that if there are some mishaps, we can easily replan and don't have to set everything again to zero. So we are very robust in executing our task, even if the execution fails. And this is just to show we have some initial state, there is a goal state, we have different available actions, and then of course it's how to connect the different actions based on what agents we have, what tools we have, such that we can really reach that goal state. And this is just an animation which shows how that is done. So we have the cooperation of human and robot. And then last but not least, a project about the inclusion and integration through cobots in the primary labor market. The motivation is, again, we want to include people which have lack of experience, lack of possibilities for the first labor market. And if effectively our solution is to also start an educational campaign. And then we are targeting different groups, and the realization is through hands-on demonstration. And the video that you see here is a video which shows some robotic workplace. We also developed a truck for that, and with that truck we are going to the different, or driving to the different target groups throughout Europe, through different regions. And I think up to now we have visited 40 to 50 different companies, fairs, institutions, and so on, to advertise inclusion and integration through cobots. Okay, I almost forgot about industrial robotics for intralogistics. In fact, I already mentioned that we work together a lot with industrial companies. This is one medium-sized industrial company in Germany for intralogistics solution, and they are also manufacturing modular fleets of AGVs, autonomous ground vehicles. And when we are talking about autonomous ground vehicles, don't mix that up with automatic ground vehicles. So these are ground vehicles which are really autonomous. There's no induction loop in the floor. They're just finding their way through sensors. And of course, we need to develop according navigation algorithms for that. And some of you might have already heard about simultaneous localization and mapping. And if you think about simultaneous localization and mapping, then that is something that humans do all day, right? You have found your way to your office by localizing yourself, seeing where you are, and of course you're also doing mapping, so you have some internal map of your environment. So that's what humans do very easily, typically, I mean. But for machines, that's much more difficult. And of course, it's also connected with path planning. But before being able to do path planning, you have to localize yourself, or the machine has to localize itself and do a mapping. And if we're doing path planning, then the traditional way would be fixed path, but autonomous path planning, it's much easier, because then it's much better to not run into collisions. And this is just an animation of such autonomous vehicles that you see here, but maybe I don't have to show the whole length of that video. This is another video, because here on a fair you see that company. In fact, the guy that you see here is one of my former PhD candidates, who at that time, like 3 years ago, was the head of the development department. Now he moved over to another company. But that's also how typically collaboration between academia and industry starts, through former PhD candidates. Okay, another example is the truck loading system that you see here. It's also about autonomous logistics, and in this case it's sort of a large forklift for 3 Euro pallets at once to be loaded into a truck, and that being done without the intervention of humans, because you know there are, especially in the food industry, a lot of companies that are producing 24/7 in the week, so it's 24 hours, 7 days a week. And this is just doing this autonomous, and in a way, even though it looks completely different, this is also an industrial robot. Okay, and where do we do the development for such systems? That is our Center of Advanced Robotics. In fact, this is just sort of animations and CAD. And if you go into that lab as it is originally now built up, then you see a lot more robots than just the few robots in these pictures. So it's also about IORT architecture for robotic units and sensors, and it's service-oriented, standardized, and of course safe access. Okay, and that now finally leads me to the Master of Science Robotic Systems Engineering. And what you see here is the project structure, where we have compulsory and elective courses. We have a German language course. I would say that language course, if you just take that one, it's not really so much about scientific discussion in German, but it's more like shopping discussion in the supermarket. That's what you can do with that language course. And then you can either do an internship or a research project. I will explain that in more detail. And of course, at the very end, there is your master thesis. So new from winter semester, we have 3 exclusive study tracks. One is focusing on data and AI. The second one is on autonomous and sensor-based systems, and the last one on development and design. And typically, you should understand that if we're talking about robotic systems engineering, then it is not only about developing, designing a robot, but it's a complete robotic systems, a complete robotic system where we have to talk about the sensors, we have to talk about the machine that is cooperating with the robot, and so on and so on. So it's a wide area that you will cover. And in data and AI, when you choose that a study track, you get the understanding of concepts, algorithm, and application of robotics, especially in the area of data. You will learn how to design such system, implement it, apply it, evaluate it, because when you're developing system, typically you always have to judge between different possibilities, and your decisions should really be based on understanding your system. So it means that you can apply artificial intelligence technologies. Okay, then the second one was autonomous and sensor-based system. So the focus is especially on sensor-based planning and control for robotic systems. I already mentioned that you need to know a lot of, or you will get to know a lot about controls also in that master course. And then it is to concentrate on the application of technical robotic systems such that you can characterize different sensory perceptions and also be able to judge on the actuator-based physical interaction capabilities. And thus, you will deepen your understanding of autonomous sensor technology, meaning that automatically the data gained from the sensors through machine learning will be produced or will be produced such that you can make that the system itself can decide what to do in order to control the system. And in development and design, possibly let's say, the most conservative of the three approaches, the three tracks, is that you gain understanding in the development and design of robots and robotic system. So you will be then the one who is able to design, implement, apply, and evaluate complex robotic systems. And if you think about the three tracks, you will see that in a real company where robotic systems are designed, you will probably always work in a group, in a team, where some have the experience in development in design, the others have the experience in sensors and autonomous control, and others know about AI and data. So I think no matter what track you are really aiming at, you will always have the possibility to later have a really good job in industry. The master course is a 4-semester course, and in the first semester there will be compulsory courses, especially, let's say, a multiplicity of compulsory courses such that all the students have a common understanding of certain abilities. There will be a few elective courses already from the first semester, and then, of course, the language course. And then towards the second semester, we have fewer compulsory courses, more elective courses, and the same is true for the third semester. In fact, the sizes of the blocks here, of the boxes, do not really represent the number of courses that you take in the different areas. What I should mention again here is either a research project or an internship. And in fact, it is such that you can not only choose among the three tracks I was mentioning before, but you can also choose whether to concentrate on research, and then you will do a research project within a research institution, either directly at Aachen universities, but possibly also outside. And if you intend to more concentrate on industrial experience, then you can start doing an internship at an industrial company, so that is possibly very interesting. And then both research project and internship will possibly directly lead you to the master thesis, which in case of research track you would do at Aachen University, and in case of industrial internship before, that internship would possibly be already a preparation for the master thesis to be performed within an industrial company. Okay, and the closing remarks are quite quick. What are the reasons to study robotic systems engineering? Well, of course, Germany is very experienced in engineering, especially also in robotic systems engineering, so you profit from that experience. And Aachen University, which is ranking, let's say, among the 2 top universities in Germany, so there you are at the forefront of cutting-edge research, and with the International Academy of Aachen University, you have a lot of support service helping you in that area. And also, as you've seen from the different projects that I showed, and well, the project I showed make up possibly like 20% of our research. So we are really prominent in mechanism theory, machine dynamics, and robotics. And we have close ties to industry, both large companies and small companies. So we also offer a lot of possibilities for master theses and research projects. And you've seen the 3 study tracks, so get a closer idea to those study tracks and decide what you want to do. And I already mentioned the intercultural possibilities that you have at Aachen University. There's one slide I didn't show today, but at Aachen University, the percentage of international students is in the area of 30%. So every third student that you meet will be a student, not necessarily from Germany, but from different companies all around the world. So I think together with the language skills that you would get, you have possibilities for a future career in Germany, but maybe also with a German company in your home country. Okay, so I welcome you to the colorful world of robots, and those robots could be industrial robots, mobile robots, human robots, humanoid robots. So these are all the types of robots that you're going to learn about in this master course. And then thank you for your attendance, and hopefully we'll see a couple of questions in the chat. And I think Nadine will lead through that.
Exactly. First of all, thank you very much, Professor Corves, for this very detailed presentation. Even I, as a non-mechanic engineer, learned a lot about robotics today. Very interesting. Yeah, guys, and please use your chance here today to really ask your questions about the program or about robotics engineering in general, because Professor Corves is really the expert when it comes to robotics at RWTH University. So please use your chance here today and ask some questions. I may add that we only have about 10 minutes time for those questions, because we need to close at 4 p.m. German time sharp. So use the remaining 10 minutes for your questions. Come on, guys. Don't be shy. Type them in the chat. I read them out loud.
You know, there are no bad questions, only bad answers.
Exactly.
And I hope to even avoid the bad answers.
There you go. There's the first one. Perfect. Kiranjay, is there research being done on ADAS and autonomous vehicles?
Yes, of course. I mean, already what you have seen from some of the videos. And then, of course, ADAS and autonomous vehicles don't necessarily need to be street cars. So there's also research being done in the industrial environment. But of course, there are other institutions like the Institute for Automotive Engineering, and they are especially working also on ADAS and autonomous vehicle. So from the number of compulsory and elective courses, you find a lot of those topics in those courses.
Mm-hmm. There you go. Questions are coming in from Sakesh. I'm passionate about the autonomous system track. Will the track open opportunities? Sorry, go up again. Opportunities for industries in big companies in ADAS, autonomous vehicles like BMW or Mercedes, etc. Mm-hmm.
I would say, of course, it does. I mean, currently you have to consider that companies like BMW or Mercedes are sort of low on hiring. But in fact, all the methods that you learn for, let's say, industrial robots, for mobile robots, can also be applied to autonomous vehicles as created by BMW or Mercedes. And from that point of view, I would say that today deciding on a robotic systems engineering master is even better, because you have the skills not only for vehicles, but also the skills for robots.
Absolutely. Sanil, you are asking, I would like to know whether master students get to work at MMI in space or environment robotics and other climate research projects. That's interesting.
Yeah, so with MMI, you're talking about machine man interaction. And of course, that's also part, in fact, as part of the courses, the lectures that we have within that course, there's also a professor from an MMI institute involved. So you could also choose from his lectures in that robotic systems engineering master.
Mm-hmm. Okay. And are there any research project going on in the field of agriculture robotics?
There are also projects going on in that area, but I also have to say it's currently not the major focus. But you can still get an idea. And in fact, in the field of agriculture robotics, I'm currently also sort of supervising a student group which has won an award in order to finance their further studies. So yes, there's also research projects going on in the field of agriculture robotics.
And we're going on with the research projects. Are there any in social or cognitive robotics?
Yes, there are. I mean, the research projects I mentioned at the end of my talk, where I was talking about inclusion of disabled people. There, of course, we deal a lot with social and cognitive robotics. So it's a lot about the interaction. It's also like observing people such that just from their behavior, we can judge on their support level that they require by the robot. So typically, let's say in the morning, when they are fresh, they don't require as much support as they might require at the end of the day.
Okay. Mitanshi, you have a background in computer science, other than what we've learned in the German engineering course. Very good, you participated. Are there any other prerequisites or some must-have knowledge I should have regarding mechanics?
I think if you attended the GEC course, especially also those courses that I was teaching, but also the courses that were taught in the area of mechanics. I understand there were also mechanics lessons there. Then that should be enough, because the additional knowledge, let's say in kinematics and dynamics that are required, they are taught in courses that are either compulsory or elective.
Okay, Kunbo. Hello, Professor Corves. I'm interested in the automatic robot guided from scan and coding and the Ford project. My bachelor project has also involved robotics in aircraft production. My question, when and how can master students join these projects?
I have to say that these specific projects are already finished, but you will find more documentation on that on our website. And there are other similar projects going on. So once you come to Aachen and you have enough time apart from your studies, then you can just drop in and get an idea of what we are doing there and how you could possibly collaborate. But I would also say that you should use the first term specifically to concentrate on the different subjects in order to see what workload that is, and then judge on how you could possibly add to that workload. Typically, in the first term, it's quite I would not say overwhelming, but it's quite a workload. And then towards the second term, third term, you get a much better feeling of what additional things, additional possibly research you could do.
Yeah, also absolutely. We as Academy also always recommend don't take too much work on already in the first semester. You will need the first semester really to settle in and get used to the workload and the new surroundings and all that. So if you're looking to do some part-time work or participate in extracurriculars, please do that only in the second semester, yeah. Good. Prabosh, a question from you. I come from an electronic background and got 2 prerequisite courses, Machine Design 2 and Mechanic 3. Will I be able to complete it in the campus? Will I have access to lectures for the same? Yeah, you're talking about our at the conditional admission offer that we have issued for you, and attached to your RoboSys admission is the condition that you still have to clear those 2 courses. You can already clear those actually this summer, okay, as part of the German Engineering College. We are offering those 2 courses as online courses. They start in July, August. I will probably have sent you already an invitation via the Master's Prep at email address. And if not, I will do so later on. But yes, you will have the chance to clear those 2 Auflagen, we call them also, even before you start your Master's here in Aachen. Good.
Yeah, regarding the next question is about someone, Jiang Bigjuan, who already learned German. And I think if you have a test of exam, then you could use your time for possibly another course that you feel will help you additionally in your studies.
Yeah, you don't have to do German as a language course. We always recommend to take German because you will be here for at least 2 years. But if your German level is already good enough and you want to learn another language, you can do so, of course. Okay. Wu Ricky, hello. I'm really interested in AI and data, but my major is marine engineering. Engineering. They are really different. What should I learn before I went to Germany?
Well, in fact, you don't have to learn, because the specific idea of that track AI and data is that you have specifically courses on AI and data that will help you in that program. So don't be afraid. If the track is called AI and data, it doesn't mean you already have to know everything about AI and data. No, you will learn that in that track.
All right, let's scroll down, please. Question from Jing Chu. Could you please recommend the key knowledge and skills that I should learn in advance during the vacation to better prepare for my master studies and upcoming research projects? Yeah.
I think that's difficult to answer. I'm sure you can decide on that by your own, because you will have access to the compulsory. You will see what type of compulsory courses are required. You can compare that with your experience. And typically, we are talking about a master course. Typically, knowledge is typical knowledge from a bachelor course. So, for instance, if you just look what you've learned in your bachelor, and maybe you feel like there were some courses that you didn't delve into as deep as you might have done given more time, then that gives you the idea what is the key knowledge and skills that you need. But in general, you will learn all that. So I would say that typically we didn't have so much the problem that people did not really have the basic knowledge in order to finish our courses.
Right, let's continue. Disha, a question from you. Is it possible to work on research project in control engineering starting from semester 1? Since I'm really interested to implement in space tech and anything related to industry.
Yeah, I think to this the same applies as mentioned before, meaning that come here, see how you do in the first term, and then only then you should decide. And it's even so that you get some expression by following the different courses during the term, but then it's yet another thing to learn for the exam, specifically pass the exam. And I think if you come here to Aachen in September, October, then a good time to work on research projects, ask different institutes, different professors where to possibly start a research project would be like April or May, something like that.
Yeah, definitely. That's what we always say as well. And you can always contact our student success managers here at the International Academy if you do have any questions regarding your curricula and how to plan your studies. Let's take a look at the clock. Only 1 more minute left. Let's see. How important is German for research in Aachen? How can we improve our English and German skills for study and research? Well, that's...
I would say German is not important for research.
Exactly.
It's not important for research. So if you want to either improve your English and German, then you should definitely opt for English. And I guess also, I guess you're coming from China, other people are coming from India. In both cases, there's a much larger variety of courses offered to improve your English than German, and possibly the English courses are also cheaper, so better to decide on that.
Yeah, I would also say improve your English if you feel you are lacking skills there. That's more important. Okay, let's take on this last question, I believe, from Sunhill. What's the possibility of pursuing an integrated PhD? Is it possible to convert to a PhD through the master's program? Yeah, right?
Yeah, I would say you don't have to convert. Typically in Aachen, pursuing a PhD and finishing the master program are two different things. Because before you can start in a PhD program, you have to finish the master. And then afterwards, typically in Aachen, you individually apply to professors whether they want to accept you as a PhD candidate. And as such, there's no specific doctoral program at Aachen University. There are possibilities of attending certain, let's say, soft skill courses while pursuing a PhD, but beforehand you have to discuss a specific topic with a professor, and in case of robotic systems engineering, that could be a professor from mechanical engineering, a professor from informatics, from electrical engineering, from computer science, and then it is always on a, let's say, bilateral base between the PhD candidate and the professor.
Yeah, guys. And as I said, I know there are a few more questions. I'm very grateful for those, but we need to cut the Q&A session here because Professor Corves actually has got other appointments to attend to.
I still have to lecture another lecture, so I have to be back to office and then to the lecture hall in time.
But I guess you can email me your questions and I can just forward them to you, Professor Corves. And with this being said, we are closing this program introduction. Thank you very much for your attendance. Thank you very much, Professor Corves, for making the time.
Thank you. And thank you to all the students.
Exactly. And before you leave the chat, please, or the Zoom session, please scan the QR code that you will see in the chat right now. It's just for us internally to give us a feedback about this webinar, what we can improve and what not, and take the time to fill this out, please. And for that, I would say thank you very much and goodbye. And hopefully we can
see you back in Aachen.
Exactly, as many of you back in Aachen in October. Thank you very much. Bye-bye.
Bye.